Okay, so our last type of energy is called potential energy. All right, so what is potential energy? Potential energy is stored energy. All right, it has the potential to do, you're missing this word right here, but it's the potential to do work. Okay, recall what work was? Okay, earlier, when a force, zoop, moves an object zoop, through a distance. That's work. All right, and then potential energy is when something has the potential to do work, can do work. That word right there is work. I know that you cannot see it. All right, next up, what are some examples of potential energy? So we have here a roller coaster that it's at the top of its, at the top of the hill. Here we have like a wrecking ball, like a crane, like it's going to be used to demolish a building. Here we have a person who has drawn a bow back, so we're increasing the potential energy. This is kind of like at the left or the right of the swing, so it has the potential there. And then this right here is a base jumper, or like a bungee jumper, I guess more so, bungee. All right, there's two types of potential energy. This right here is the new stuff. This is what you need to pay attention. I know that you all know what kinetic energy and potential energy are. You need to know what kinetic energy, you need to know the two different types of potential energy, okay? They're pretty self-explanatory though. You have elastic potential energy and you have gravitational potential energy. All right, so in elastic potential energy, you can see from these videos, from these pics here. All right, this is a slingshot. We are increasing elastic potential energy by pulling this back. Okay, same thing with the bow. You're increasing the elastic potential energy by pulling the bow back. And then over here on the top right, you're compressing the spring. Okay, so the definition of elastic potential energy, I know it's a little bit covered up, so pay attention. It says elastic potential energy, the potential energy associated with objects that can be stretched or compressed. Stretched or compressed. So you can see here on the left hand side, those two pictures are being stretched, and then on the right hand side, that's being compressed. So things that are elastic, literally like rubber bands, bows, stuff like that, in order to increase the elastic potential energy, you're going to stretch them. Whereas things like springs, which are coiled, in order to increase the elastic potential energy, you compress it, make it smaller. And then gravitational potential energy is potential energy that depends on height. You cannot see that either, but it is height. That's the word you're looking for. Gravitational potential energy is the potential energy that depends on height, H-E-I-G-H-T. Okay, so here's the deal. Here, anybody know where this is taken? It's at King's Dominion. I don't think they even have this route anymore. It was super, super, super short. But it was pretty cool. So you have this this rod, maximum gravitational potential energy at its highest point. This guy is pretty precariously placed, and you can't really see this guy right here, his feet, but his feet are right here on a rock, and he has lots of gravitational potential energy because he's way, way, way high up. All right, so you can actually see all the words on this slide. That's awesome. So potential energy, elastic potential energy, the greater you stretch or compress an object, the greater its elastic potential energy. Makes sense, okay? You take a rubber band and you stretch it just a little bit. That's not very much elastic potential energy, but you stretch it a lot. It has a lot more elastic potential energy, so you can fling it. Ouch. Not a good idea. All right, gravitational potential energy, the greater the weight of an object, or the higher that it's lifted, the greater its gravitational potential energy. Oh yeah,